uh, test the series sum k equal 1 to infinity ln of k divided by k for convergence or divergence. For convergence or divergence. So let's see. So we have this sum. So we could do, actually I think we already did. Yeah, we did a similar one, right? We did just this one before. We solved this one using the integral test. Okay. So but we can solve it in another way. So that's what I'm saying. You can have, you can solve it more than one way. As long as you are using it right, it's fine. So we solve this problem. We solve this problem using the integral test. But now let's use comparison test. So we have the sum of ln of k divided by k, and k equals 1 to infinity. Okay. So you consider the term ln of k divided by k. So we need to compare this with some series that we know that is convergent or divergent. So what could be a series that looks similar to this one that maybe we can compare with? Somebody can tell me? So this series looks like what? Like something we know. So remember, we don't know that much. These are the series we know. We know geometric series and we know P series basically. That's what we know so far.
Can we use P series?
Yeah, which one? Which one you could try?
1 over n.
Yeah, we could try 1 over n. So because you see, this is, it says ln of k, right? So well, let's put it. Let's put n. You can put n. It doesn't matter. The k. The k doesn't matter. You can call it k. You can call it I. N. Ln of n over n. And ln of n over n. So let's put 1 over n. So the question is, who is bigger? Turn by turn. So how do you do this? So you had to start with ln of 1 over 1, and you have 1 over 1, right? Then you have ln of 2 divided by 2, and then you have 1 over 2. Then you have ln of 3 divided by 3, and you have 1 over 3. And so on. So for the first one, what is ln of 1? So ln goes like this, no? What is
Would it be 0?
0? So this is 0. So this one is bigger than that one. What is ln of 2? Ln of 2, we can look on what is ln of 2? ln of 2. Ln of 2. 0.69. So 0.69. So 0.69 divided by 2, we get 0.345, right? So 1/2, so still this bigger, right? But you cannot just, you cannot stop that. You need to do more. Because ln is increasing. See, ln of 2, ln of 3. You see, this is ln of 1. ln of 1 was 0. Then ln of 2, this is 1, this is 2. Then ln of 3. So basically you want to compare ln of 3 and 1. So when you check ln of 3, that is ln of 3. Let me change it for, I can just do it here. Ln of 3. That's 1.09. So if you compare here, this guy is 1.09 over 3. So this one is bigger than that one. And you see, logarithm is increasing. So from now on, ln of n over n is bigger than 1 over n. Okay? So the first one could be misleading, but ln of n divided by n is bigger than 1 over n. Because ln is increasing, and 1 stays just 1, right? And n is equals n. So this is for n bigger or equal than 3. So for n bigger or equal than 3, ln over n is bigger than 1 over n. So what do we have? What do we know about 1 over n? What do we know about the sum 1 over n equals 1 to infinity? This is convergent or divergent?
This is divergent.
This is divergent, right? We'll reprove it by integral test. And it's a p series with p equals 1. So p series, p equals 1. That's what is divergent. So, but this is bigger, this is smaller than sum of ln of n divided by n equals 1 to infinity. Okay? So since this one is divergent, and this series is bigger than a divergent series, so what happened? Is this series divergent or convergent?
Divergent?
Divergent. It's divergent by the comparison test. Okay? So remember we have here the comparison test. It was here. If b sub n is bigger than a sub n, and the sum of a sub n is divergent, then the sum of b sub n is divergent. Okay, so by comparison test is divergent. By comparison test, the sum of n equals 1 to infinity of ln of n over n is divergent. Okay? Okay. So yeah, we got that one. So so basically we have now the geometric series, the p series, the integral test, and the comparison test. So we have a lot now. Okay, so let me give you more. The next one we're going to do is the limit comparison test. This is a good one. I like this one. But you need to be good at limits. So there is no choice here. You are good at integration, use the integral test. And so hopefully it will work. You got a limits. This will be very useful. It's called the limit comparison test. So it says, suppose that the sum of A sub n and the sum of B sub n are series with positive terms. So I mean A n bigger or equal than 0, B sub n bigger or equal than 0. Okay, so if the limit of A sub n over B sub n when n goes to infinity equals a constant, where C is a finite number, and C is bigger than 0, then either both converge or both diverge. Both series converge or both diverge. So I like this one because it's like a marriage, okay? And this is really important, really interesting. So if you can find the limit of the quotient of two series, or of the general term, not sum. There is no sum here. Just the general term a n over b sub n. Both converge or both diverge. That's very nice. That's very nice. But again, you have to be good at limits. So let's test ourselves. Let's see. Can we solve this? The one that we just solved using limits or not? So let's see what happened. So let's see what happened, because so test the sum of ln n over n equals 1 over infinity. Okay. So we're gonna see if the comparison, if the, what is it called? Comparison limit test works. For the one we just saw, limit comparison test. Let's see if that one works. So we're gonna compare. Let's compare it with the sum of 1 over n equals 1 to infinity. So let's go. Limit n goes to infinity. So the question is, do you want to put it on the top or do you want to put it on the bottom? Right? It look like we can do either way. So whatever the limit is easier. So let's do both to see what limit I can find. Okay, that's like real life. Just like doing jazz. This is improvisation. So how will solve this problem using this test? Okay, so I can find that limit, or I can find this limit. So I have A and I have B. I like better B, because when I do the multiplication, I get limit n goes to infinity, and then gives me n over n. So it gives me n times 1, n times ln over n. So this n cancel with this n, and I get 1, right? So I got the limit of n goes to infinity of 1 over ln of n. And what is this limit? This limit is 0. Okay, but you have to be careful, because they're saying here c must be bigger than 0. So we cannot use the limit comparison test for this one. Okay, so you have to be careful, and I'm gonna copy paste this test, so you have to read it and you have to be careful. So c has to be bigger than 0. So let's put c bigger than 0. So in this case, doesn't work. The other limit, if I do my other limit, what do I get? If I do my other limit, I'll get limit n goes to infinity. So I'll get ln of n times n divided by n. Cancel. I will get infinity. So in both cases, it's telling me I cannot apply the comparison test. It basically is not telling me anything. Okay, basically it's telling me I cannot use the limit comparison test. I cannot use the limit comparison test. So let's see an example there where I can use it. So remember, I give you one before we didn't do. I put it here. This one, we haven't solved this one. I put it a long time ago. Well, last class. We said that the number A was convergent using comparison tests, using geometric series. The other one, the comparison test wouldn't work. You could try it, but I think that series might be convergent. Okay, and the problem is that. So let me put it here. Well, let's check first. How do we solve it? And then we discuss why I cannot use comparison tests. So example. Test the series sum n equals 1 to infinity, 1 over 2 to the n minus 1. Test the series for convergence or divergence. Okay, so which one would you like to compare it with? I mean, it must look very similar so we can compare it. So which one would you like to compare it with?
The 1 over 2 to the n.
Yes, correct. So, let's use this test. So you need to do limit n goes to infinity. So, okay, let me put it here. Let's compare with the sum 1 over 2n, n equals 1 to infinity. Okay. So you can put it, let's do both. Because it's not, I don't want to give you just the right way to do it right away. Let's explore. So let me give you 5 minutes to find both ways. So you can put it on the top, 1, 2 to the n minus 1 over 1 over 2 to the n. You need to find that limit, or put it on the other way around. Limit n goes to infinity, 1 over 2 to the n over 1 over 2 to the n minus 1. So one weakness of the YouTube videos is they just do the problem right away because they have 5 minutes. They usually they don't want to make a video longer than 5 to 10 minutes because that's kind of YouTube, right? You wanna don't lose the audience. So sometimes they don't explore. Okay, so that's you just see somebody doing the job for you. So in that sense, I don't like it. So if you watch all these YouTube videos, stop the problem, do it yourself, try to do it yourself, explore, and once you got it stuck or you got it, but you don't know if it's right or not, then see the video. So the next question is, you did it different, and you don't know if you are right or wrong. Well, you can ask me, okay? But be careful with these YouTube videos, okay? It's not the same of running yourself that see somebody else run, or playing soccer. You see the Champions League, you think soccer is easy, right? But you start trying to do the same those guys do, and then you see how difficult it is. So try to find both limits. If you find any limit, it's fine. That will prove that if you find that limit is a number, that will prove that both series are convergent because this 1 over 2n is convergent. The series 1 over 2n is convergent. It might be the case that one limit is too hard, but the other is easier. So it doesn't matter. So choose the limit you think is easier. So choose A or choose B. Okay, so go ahead. So let me give you 5 minutes to do this, to find those limits. What do you guys get? Somebody got any limit? Somebody said 1. Somebody got 1? Somebody else got 1? Another limit? So let's see. Let's do the first one to see what happens. So you see this, I do my product. Okay, so I call it the EAR law. That's multiplication, division of fractions, right? So I get limit of n goes to infinity of 2 over n. No, sorry, not 2 over n. 2 to the n. And then 2 to the n minus 1, right? Now, how can I find this limit? So I teach you a little trick before, remember? How do we find those limits? So you divide by the biggest power. So these are nice when the biggest power is 2 to the n, 2 to the n. So I divide everything by 2 to the n. So if you want to do it rigorously, you're going to multiply the top and the bottom for 1 over 2 to the n. So you are multiplying times 1 because, you know, these guys will cancel, right? But I'm going to, instead of canceling them, I'm going to expand them. So I will get limit of n goes to infinity. I get 2 to the n divided by 2 to the n over 2 to the n divided by 2 to the n minus 1 over 2 to the n. Let's see if people is talking. I got 1, I got minus 1. Okay, let's see. So when you simplify, this simplify with this guy simplified with this guy. So you get limit n goes to infinity of 1 over 1 minus 1 over 2n. So when limit n goes to infinity, the guy on the top goes to 1. This guy goes to 1. This guy goes to, where is 1 over 2 to the n when n goes to infinity? Where is that going? This guy goes to 0. So this limit goes to 1 over 1. That is 1, right? So you see, this trick is very useful. So let me define the other one. Same technique. So we multiply limit n goes to infinity. So you multiply like this. You get 2 to the n minus 1 divided by 2 to the n. Then this is even easier. Then I expand my fraction. So I get 2 to the n over 2 to the n minus 1 over 2 to the n. I simplify this guy, so I get limit n goes to infinity 1 minus 1 over 2 to the n, and this guy goes to 0. So this is 1. Okay. So either way, you put it, you compare, you can put it on the top or on the bottom, you can switch it, and then you'll get both limit equals 1. So therefore, by the comparison limit test, or the limit comparison test, so therefore, let me say it. You just need to find one limit. You don't need to find both limits, okay? You just need one limit. I just doing it because some people might do it when you are doing your homework by real. You are gonna ask yourself what I put on the top, what I put on the bottom. The answer is it doesn't matter as long as you can find the limit. So probably you just have to try both, okay? And you go for whatever limit you can find. So by the limit comparison test, both are convergent. Since the sum of where 1, 2 to the n is convergent, then the sum of 1 over 2 to the n minus 1 is convergent. Okay? Okay, sorry, we cannot be. Somebody's asking me the limits always get the same result. No, I don't think so. Maybe the limit exists. I don't know. That's a good question. I think in the answer, in general, the answer is no, because look at the example over here. One limit gives me infinity, and the other quotient gives me the limit 0. So I think that in general, the answer is no. You switch them, the quotient is going to give you different limits. Okay, so I don't think, in general, it's not true. Maybe that some cases it's true. Okay. Maybe if the limit is different of 0, maybe. I'm not sure. We'll see if we can show an example of that. By the way, this is called analysis. That's the limits always give the same result by A and B. That's the limits always give the same result by A and B. Oh, that's the same question. Sorry. Already, I guess I answered that. So they don't give always the same limit. Okay, so let's see, what time is it? So 2:40. Let me see, I have to do the alternating test. Before going to that, let me do more examples. Okay, so let me give you more examples, more exercises, since today's Friday. Let's do more examples. So let me give you of this comparison test. Let's do this one. Example. So the first one is the sum n equals 1 to infinity 1 over n squared plus 1 convergent or divergent? So go ahead. Let me give you 3 minutes to solve that one. And let me give you another one. 2. Same question for, let's see. This one is the sum n equals 1 to infinity of 1 over square root of n plus 1 convergent or divergent? Okay, let's do those. Let's do those two. So let me give you 10 minutes. Okay, this is important. These two could be one exercise for the test. Okay, for exam number 3, or even for the final. So go ahead. So try to spend 10 minutes doing this. Okay, let's try the first one. How will you solve the first one? What test would you use?
Comparison test.
You can do comparison test, yes. So what could be, how can you do that? So compare it with what?
A P series.
Which one?
1 over n squared.
Yeah, so let's try that. So sum, let's compare with sum 1 over n squared, okay? So we're gonna put 1 over n squared plus 1 and 1 over n squared. So which one is bigger? A or B?
B.
B. So we need to prove that, okay? If you don't do that, you're gonna lose points in the exam. So you need to show me why B is bigger than that. So this is bigger. Why? So reason n squared plus 1 is bigger than n squared, right? This is no need to prove. Everybody believes this. You have something and you add 1, well, that extra one is bigger than n squared. These two guys are the same, right? But right now, by properties of the inequalities, if I switch them, 1 over n squared plus 1 n squared is correct. So this is correct because of this, okay? Now, this is true. So then, since the sum of 1 over n squared is convergent for being P series, P equals 2, then the sum of 1 over n squared plus 1 is convergent. Let me erase this. This is convergent by the comparison test. Okay? So by comparison test, this is going to be convergent. Now, somebody did it in another way. Somebody tried to use the limit theorem, the comparison limit test. Nobody? Well, let's do it. Let's try it. But you know, it's similar. Of course, this is easier. If you figure that you had to compare with n squared, well, yeah, but you had to prove this inequality, okay? Don't forget this. This is critical. N squared plus 1 is bigger than n squared. Otherwise, I'm gonna take 2 points off or something like that. If you don't do this part, I might take 2 points off. So let's say you wanna do limit. So let's compare limit of 1 over n squared plus 1 by 1 over n squared. N equals 1 infinity. So I'm good with limits, so I don't care. I don't worry really who goes on the top or who's going on the bottom. It must be very difficult for me to not be able to solve it. So I do this, limit n goes to infinity, then n squared equals n squared plus 1. So how do we find this limit? By the way, I'm not bragging, I'm advertising. So limit is power. You cannot keep hiding from the limits, okay? They're gonna get you. So the next 3 talks are just about limits, and even hardest limits than this one. So your days of being afraid of limits are over. It's something you have to handle and just put the hands on. So what is this? How can I find this limit? We have done 3 times this limit before. How to find this limit?
Using L'Hopital's?
Dividing by the biggest power.
I think both answers are correct. You could use L'Hopital or you can divide by n squared. Yeah. But to go L'Hopital, you have to go to limit x squared divided by x squared plus 1. X goes to infinity because it's continuous. So you want to do L'Hopital, you do limit x goes to infinity, 2x over 2x. They cancel. So that they get 1, right? So the limit is going to be 1 by L'Hopital. So I like that, but you need to go, you have to do that clarification. However, I like that idea. But easier way, divide by n squared everything. You get limit, n goes to infinity, 1 over 1 plus 1 n squared. And then this goes to 0, this goes to 1, so 1. Okay. So there are many ways to, you see, like right here, there are like 3 different ways to solve this problem. Okay. So discover your own way. Don't try to copy somebody. Don't try to follow somebody. You know, it's like factorization or something like that. You do your own way. Okay, so don't try to understand why other people is doing like that. So your brain is extraordinary. It will do things totally different than other people. So give the advantage, give the opportunity to your brain to show. So what is this? What about this one? What do you guys do for that one? Did you solve that one or not?
I solved that one by using the comparison test again.
The comparison test?
Yes.
Which one you use?
I used P series.
Which is, what is P?
It's 1 over square root of n.
Okay. So let's see, because I don't think it works. Let me show you. So, but that's what I need, that you guys tell me what you're doing so I can tell you, okay? So we try 1 over, let's compare with, sum of 1 over square root of n, right? So, so we know this one is divergent or convergent? This one.
Divergent.
Divergent. So we need to figure out which one is bigger, if this guy or this guy. So we go to fractions, not to fractions. We do the opposite. So let's look the, how will we call it? Reverse. Let's look the reciprocal. Let's call it somehow. Is that reciprocal good? I will call it reciprocal. I'm not sure if it's correct. If we look at the reciprocal, it will be something like this. Who is bigger? A or B?
A.
A. So this guy is bigger than this guy. Therefore, this guy, the quotient is smaller than this one. So this one is bigger than that. But this one is divergent. Can I conclude that this one is divergent? No. Okay, so this is important. Very common mistake. And I'm glad I can fix it now and not during the exam. So the comparison test is useful when, to use comparison test, you will need this way to show that this one is divergent. Okay. So the smaller one, so in this case, the bigger one is a divergent. So you cannot use one to prove that the smaller one is divergent. Remember, it's a case of, is base of areas. Okay. So this one doesn't work. So we cannot use we cannot use comparison tests. But we already checked that sometimes the comparison tests don't work, but then the limit comparison test might work. Because we are so close, right? It looks like we are so close, like we almost got it. So you are in the right track. So how do you fix it? So let's use limit comparison test. So let's compare limit of 1 over the square root of n plus 1 over 1 over square root of n. N goes to infinity. So let's use the limit. So if I do my quotient, goes like this, limit n goes to infinity, then we got square root of n divided by square root of n plus 1. So what do I do now to find this limit? That's the trick of the day. What is it? What I'm gonna do?
Divide by the biggest, what is it? Divide by
the biggest
n
power,
square
whatever.
root, or square root of n.
Yeah, so in this case, square root of n. Square root of n plus 1 over square root of n. Now this is cancelled, this cancelled. So I get 1 limit n goes to infinity of 1 over 1 plus 1 over square root of n. Okay, so when n goes to infinity, this guy, where this guy is going? This guy is going to 0. So therefore, the limit is 1. Therefore, by the limit comparison test, both series convergent or both series divergent. So we know that okay, let me write it down. By limit comparison test, both series diverge since the sum of 1 over square root of n is divergent for being a p-series with p equals 1/2. Okay, that's how you solve those. So you see, you already have kind of the idea. So when comparison test doesn't work, to the rescue comes the limit comparison test. If comparison test doesn't work, limit comparison test doesn't work, I will go by the integral test to see what can I do. Okay, but there are more. So let's see what are the other ones we have. So we have one more or two more. We have three more. But so this is the section of today basically. It's called the alternating series test. Let me make a new one. I'm gonna call it alternating series test. Alternating series test. So let's do alternating series test. So There is one classical one, so let me do that one. Yeah, so we know that this one is divergent, right? 1 plus 1/2 plus 1/3 plus 1/4 and so on. This is divergent. We prove it like 3 different ways because it's a P series, but basically the integral test. And sorry, I was sneezing. Okay, so this is the divergent test. So what about this one? 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus so on. So this should be the sum on minus 1 to the n, 1 over n, I will be n plus 1. N equals 1 to infinity. So when n is 1, 1 plus 1 is squared, so minus 1 squared is 1. So we get 1 minus 1/2 and so on. So you see this is alternating. So here you are always adding a number, but here you are subtracting sometimes. So you are adding and subtracting, adding and subtracting. So is this enough for the series to be convergent? The answer is going to be yes. It's really cool that we can fix this series, okay? Again, this goes to infinity. So let me tell you a story here because this is kind of, you are privileged, okay? You are privileged of receiving this kind of education of series. So I remember when I was a student, I was doing my PhD in Arizona. Once I got I met a guy. He was uh, homeless, and so you take those buses that go around the university, and you find a lot of them because they go to the downtown. So I sit next to him, and then he started talking to me. He said, "What do you study?" I said, "Math." He said, "Oh, you study math?" I said, "Yes." So he took a notebook, a whole notebook, and opened it. He showed me a series. It was a geometric series. So he was showing me that he found this pattern, that he was doing this, and that he found the sun was this number. And when I look at it, it was geometric series can look very weird. So I look at it and said, "Oh, but this is a geometric series." And he's like, "What? Do you know this?" I said, "Yeah, this is a geometric series." And then the whole notebook was any kind of geometric series. See, he was trying to do mathematics by himself, and he discovered geometric series. That was really good. And but I told him, there are more series. There are like arithmetic. There are all this any kind of stuff. So you're privileged because I don't know how much time of his life he spent learning this by himself, but you're learning this in less than in a week. Okay, so this is the privilege of being at the university. So let's do let's learn the alternating test. So this goes like this. So this is sum n equals 1 to infinity minus 1 n to the minus 1 b to the n. So basically, but let me call it alternate. No, sorry. Let me call it alternating series test. So alternating series test. And there's the sum of n equals 1 to infinity minus 1, n minus 1, b sub n. And then you'll get, this is b1 minus b2 plus b3 minus b4, and so on. Okay? So this alternating series, and here b important, bn is bigger than 0. Okay? So you don't worry. You say bn is bigger than 0 and is alternating. Okay? So you have to worry if these bn are positive or negative. They are positive. So notice that in these problems, until now all these series were positive. Okay? And again, all this mathematics is the base of mortgage. I mean, I pay. How do you calculate your mortgage? I calculated myself. Okay, my house. But I don't know. They do it in a different way. I was calculating the numbers and I got different numbers. I don't know what I did wrong. I think they start changing the formula somehow. They do it not exactly. So they have some specific formulas. I still don't know what I did wrong. But you can do these calculations by yourself. So all these series are very useful in mathematical finance. Okay, so that's why you can see engineers being in high ranks positions in banks. You know, at least in Colombia, I was like that. You could see people with industrial engineers being in charge of a bank. So you wonder why? But because they understand the math. So part of this also, they has to be decreasing. Okay. So condition, they must be decreasing. The sequence must be decreasing. Decreasing. Part 2, the limit of the b sub n goes to infinity is 0. Okay. Then the series is convergent. So these problems are like anything. You are gonna get a lot of trouble with the first problem, the first 5, 10 problems. But after a while, you're just gonna identify the problem like this, really fast. Okay. So when you see an alternating series, like it's going positive, negative, you just said, oh, well, this has to be alternating. Okay. Or integral test. Integral test couldn't be. So it has to be alternating. In that sense, this is gonna be one good problem for you. When you see this problem, you have to solve it. Okay. Because you can identify right away what it is. So let's check that one indeed is the one over here can be solved using the alternating series test. So example, sum of minus 1 n to the minus 1 over n equals 1 to infinity is this series convergent or divergent? Okay, so what we need to check. So first question you must ask, what is Bn? What is Bn in this problem?
1 over n.
1 over n, yes. So Bn is 1 over n. You don't worry about the negative stuff. because that's part of any alternating series. So the first part that you need to check is, well, yeah, you can check 2, right? 2 is easier than 1. So 2 is the limit. Is this limit goes to 0? Limit of 1 over n when n goes to infinity. Is it 0 or not? Yes or no? Yes, that's the easiest limit we know. This is true. This is 0. And the second part, is this true? That bn plus 1 is less or equal to bn. That means decreasing. Is this decreasing? So is bn plus 1. Is bn plus 1 less than bn? So bn is 1 over n. What is bn plus 1? What is bn plus 1? If bn is this, what is bn plus 1?
Is it 1? Is
Yes.
it 1 over n plus 1?
Yes, correct. So this is 1n plus 1 is less than 1 over n. We are asking this. Is this true or not?
Yes.
Yes, because by the reciprocal, let me call it reciprocal. I'm not sure if I'm calling it correctly, but by the reciprocal, I need to call it somehow. Because this is important, okay? So by the reciprocal, n plus 1 is bigger than n, right? So therefore, this is true. Because when I invert the fraction, it's gonna go like this. The inequality, that's by inequality properties. By inequality properties. Okay, so we have Bn is positive. So Bn is positive, yes. We have Bn plus 1 less or equal to Bn. That's also correct. And 2, the limit goes to 0. The limit goes to 0. Therefore, by the alternating series test, the series is convergent. So the series, since 1 over n is positive. Okay. Since 1 over n is positive, 1 over n plus 1 is less than 1 over n, and the limit of 1 over n goes to infinity is 0, by the alternating series test, the sum of minus 1, n plus 1, 1 over n is convergent. Okay? Okay, so with that we can stop today. So next, on Tuesday, I'm gonna do one third that is absolute convergence test, and the final test, ratio test. And then we are done with this ratio test and root test. Then we're done, and we can start power series. But on Tuesday, I'm gonna do those tests, and we're gonna mix. We're gonna probably see the web work, homework, and try to see all these ways to do it. But I wanna give you all the tools so you can solve your homework in more than one different way. Okay? So you just need to get good at it. Okay? Okay, guys. So I don't have anything else for today. So I will see you on Thursday and Tuesday. Okay?
See you, sir.
Okay.
Yes, sir.
Okay. Bye.
Thank you, sir. Good day.
Okay. Bye. Have a nice weekend, guys.
Bye, sir. Have a nice weekend.
Okay. Bye.